So the topic that we will be covering today is binary searching. And binary searching is an easy to use search method that can be used to find any specific element in an array. Now binary searching already assumes that the array is sorted in either ascending or descending order. However, it does not matter which one. Now for an example, we're going to look at the pack of cards that we have here. And as you can see, they are ordered in ascending order from 2 to 10. Now say we want to find the number 7. One way we can find it is to go and start from the lowest number, which is 2, and ask, is 2 equal to 7? No, it's not. Is 3 equal to 7? No, it is not. We can do it this way, but it is inefficient and can take a long time, especially if there are a lot of cards that we are searching through. With binary searching, we basically go and we split the deck in half, and we're going to look at the card in the middle. In this case, it's the number 6. Now we'll go and ask ourselves, is number 6 equal to number 7? Obviously not. Now we'll go and ask again, is 6 greater than 7? No, it is not. So now we can go and eliminate all the cards, including number 6, that are less than 7. So all the cards here we don't need anymore. And that means we are left with 7, 8, 9, and 10. So now basically we're going to go and repeat the same process. But here we can see that there is an even number of cards. So for the middle card, we're going to go look at the one on the left from the middle. This is explained why in the second part of the video. So now we'll go to number 8. We're going to ask, is 8 equal to 7? No, it is not. Now we're going to ask, is 8 greater than 7? Yes, it is. So now we're going to go and eliminate 8, 9, and 10, since they're all greater than 7. And then we're going to look at the left side of where number 8 was. And that leaves you with just one card, which is 7. Let's say if there were 2 7s in the deck, and we want to find both. Basically, you would do the same process as you were to do with binary search. But once you find the card that you're looking for, you would have to continue the search for other 7s that may be beside the 7 that you have found. So you would again look on the left side and the right side, and you would find the other cards that are the ones that you're looking for. So that's it for the unplugged part of the video, and in the second part we will implement binary search in Java code and show you how it works.
Today we'll be discussing the binary search algorithm, one of the simplest and most efficient searching algorithms in Java. Binary search works by dividing an array in half and then checking the value at the middle and comparing it with the target value. And if the value at the middle is greater or less than the target value, it'll divide the array further. For binary search to work, the array must already be sorted in either ascending or descending order. So here is the binary search method that I've created. As you can see, it takes 2 parameters, a double array and a double. So in the method, you can see we have several variables. The first of which is the int bottom, and this represents the lower bound of the array. So that's the lowest index of the array, and we've initialized it to 0. Next is int top, and this represents the upper bound of the array or the highest index of the array, and it's been initialized to the list length -1. There's also int middle, which represents the index at the middle of the 2 values. Then there's also boolean found, and this represents whether or not the item has been found in the array, and it's initialized to false. And lastly, there's int location, which represents the index at which the item was found. And here it's been initialized to -1, so if the item is not found in the array, -1 will be returned. So, the first part of the method is checking whether or not the array is in ascending or descending order. So here we have an if statement that checks if the last value in the list is greater or equal to the first value of the list. So if the array is found to be in ascending order, we move on to a while loop, which checks if the bottom is less than or equal to the top, and it checks if found is not true. Then we find the value of middle by adding bottom plus top and dividing by 2. This middle variable represents the index that's being checked. So if the list at middle equals the item, then we change found to true, and we change the location to the index middle. However, if the list at the middle is not equal to the item and is actually less than the item, then bottom will equal middle plus 1, so bottom will move up. This means that we're only looking at the top half of the array. But if list middle is greater than the item, now top becomes middle minus 1, so now we're looking at the bottom half of the array. Finally, there's a return statement that returns the location of the item. Now, if the array is not in ascending order and is actually in descending order, we use a similar process to find the item. Middle is still found by adding the bottom and top and dividing by 2. And if list middle equals item, then we change found to true and location to middle. But now, if list middle is less than the item, top equals middle minus 1, and we look at the bottom half of the array. And if list middle is greater than the item, bottom becomes middle plus 1, and we're looking at the top half of the array. There's also a return statement that returns the location of the item. So now let's trace through the program. Here we have a double array that consists of 7 items, and we also have their index numbers here. Let's say we wanted to find the number 15 in this array. So now we have to determine where bottom, middle, and top are in this array. Since bottom is going to be initialized to an index of 0, we know that the value of 1 is going to be the bottom. And since top is going to be at list.length minus 1, it'll be the last value. So it'll be here. So the middle will be found by adding the indexes of the bottom and top and dividing by 2. So 0 plus 6 divided by 2 would be 3. Now we're going to compare the value at middle with the target value, which is 15. Since 10 is less than 15, now bottom becomes middle plus 1. So that means that bottom is now at an index of 4. Now we'll find the new middle, so that'll be adding 4 plus 6 and dividing by 2, so that'll be 5. So now this will be the new middle. Now we'll check again by comparing the value at middle with the target value. So since 21 is greater than 15, now top becomes middle minus 1. So now bottom and top are both at index 4. So to find the new middle, we'd have to add 4 plus 4 and divide by 2. So we'll get a middle at 4. Now we'll check again if list at middle equals the target value, 15. So since the list at middle equals 15, we now know that the item is at an index of 4. That means we change boolean found to true, and we return the location as an index of 4. So if we were to run this in Java, like this, we should get the same result of the item being at an index of 4. And yes, that's what we've got. Now if we were trying to find an item that wasn't in the array, like 16, we would get a message saying that the element was not found in the array. Alright, thanks for listening, and I hope you learned something new about binary search.